Okay, thank you. Yes. So in the previous class, we were discussing silicon controlled rectifier. Very simple structure, PN, PN. Okay. Extreme two regions are heavily doped. The first P region, first and last N region, okay, heavily doped. Middle two region, slightly doped, right? Okay. Symbol of SCR is this. Something like a diode, but additionally you have a gate terminal, additional gate terminal. Okay. Now we will see the characteristics shortly, and then you will understand why the symbol is like this. Okay. Next, we considered in the previous class, we have taken, okay, basically we were studying two cases. First case, when gate is open, forward bias, reverse bias. Okay, right? So when gate is open, forward bias means at the P side, we will connect positive. At this N side, okay, we will connect negative of the supply, right? Then what we have seen, when we gradually increase this forward voltage, okay, the characteristics will be like this. At one point, this junction J2 breaks down, okay. So suddenly this junction breaks down, right? Okay. So when the junction breaks down, thereafter current can flow large. So the characteristics will be like this. Next, from this point, okay, to this point, right? Okay, it is called as forward blocking region from origin to this point. Still the device is off, current is negligible, right? So it is called as forward blocking region from origin to this point. Okay. Likewise, next, say from here to here, the device is in on state. Okay, forward on state, right? Okay, and we have seen this as class also told you. This is forward breakover voltage. It is that voltage where this junction J2 breaks down. Okay, right? Next, what happens under reverse bias condition? Reverse bias condition means we have, okay, reverse bias condition means we have discussed, right? P side negative and N side positive. Okay. Now there you have two, okay, reverse bias junctions. One is this P side negative. So this is reverse biased. N side positive. So this is reverse biased. So you know, whenever junctions are reverse biased, we have depletion region. Okay. So two depletion regions we have seen in the previous class, right? Across J1, J3. So when we gradually increase the reverse voltage, okay, then obviously because you have reverse biased junctions, the current is negligible. But at one point, the junction breaks down, same mechanism, which is avalanche breakdown. Okay, the avalanche breakdown, same mechanism. What you have in an ordinary PN junction diode, the same mechanism is responsible. Okay, right? And the voltage at which the two junctions break down, okay, that is the reverse breakdown voltage, this point, represented by VBR. Okay, right? And from origin to VBR, from this point to this, it is, okay, reverse blocking region. From origin to VB0, it is forward blocking region. From origin to VBR, it is reverse blocking region. Okay, because the device is off, blocking. Okay, all this we have seen in the previous class. So that was a quick revision, right? Now, what we have done, we have taken gate is open, okay, and we have analyzed. So obviously the next case that we will discuss, okay, all this we completed in the previous class. The next case that we will consider is when gate, okay, when the gate is closed. Okay, next, when gate is closed, right? Okay. So second case, we will consider what happens when gate is closed. Okay. What do you mean by gate is closed? Very simple. Okay. To this structure, to this structure, additionally, we will connect a voltage. Okay. Additionally, we will connect a voltage here, right? So that is what is gate is closed. Okay. So to make it faster, what I will do, I will edit this one. Okay. So what do you mean by gate closed? Okay. What do you mean by gate closed? So to make it faster, I am just editing this. So what do you mean by gate closed? Means, okay, here we are connecting an additional voltage source. Okay, we are connecting a additional voltage source there. Okay, so this is the meaning of gate closed. Okay, this is the meaning of gate closed. What do you mean by gate closed? We are same circuit. Okay, additionally, from gate, okay, between gate and this cathode, we are connecting a voltage source. Okay, right? That is the meaning of gate closed, right? So what is the purpose of this gate closed? Is to supply the gate current. Okay, the purpose is to supply the gate current Ig, right? Okay, so now we will consider what happens if we give gate current, right? Okay, so we know very well that whenever we give gate current, okay, right, whenever we give gate current, so let us see, okay, the current, see here what is happening, this PN junction, now we are considering the PN junction J3, P side we are connecting positive, N side we are connecting negative, so J3 will be now forward biased. Okay, correct, simple, same point, P side positive, N side negative, so forward biased. Okay, so junction is forward biased means current will flow like this. Okay, clockwise direction, right? But you know, electrons are negatively charged. So current is flowing in clockwise direction means electrons are flowing in what direction? Anybody quickly answer? Electrons are flowing in what direction? Anti-clockwise direction. Okay, quickly answer. I hope all of you know the answer. So just quickly answer. So what is happening here? The free electrons are flowing like this. Okay. N region has free electrons, right? So they will flow like this, right? But all of these free electrons, they don't flow in this path. Some free electrons, what they will do is, okay, so this is like, say, something flowing like this. Suppose, say, cars are at very high speed, they are going in circle. Okay, so what happens, due to high speed, some cars, instead of going, okay, left, they can go straight, right? They may skid and they won't go straight, right? Same mechanism happens here. Actually, the free electrons should be flowing like this, but they gain sufficient high velocity, they will pass through J2 and they will go into the anode terminal, okay, like this, right? So instead of charge carriers going like this, some charge carriers, they go like this, they go like this. So because of that, this anode current or the forward current, okay, starts to increase, right? Okay, so when this current increases, when this particular current increases, so see, suppose if you take a pipe of water, if you suck water, okay, then what happens? From the drum, water will come into your mouth, right? So because the free electrons are going like this, the similar action what I just explained takes place. More number of free electrons will break this junction and they will reach, okay, anode, right? So because of that, anode current further increases. When this current further increases, then again more number of charge carriers will further break this J2, okay? Because free electrons are breaking J2, anode current or the forward current increases. Because the forward current is increasing, okay, the free electrons breaking J2 increases, and because of that, anode current increases. One is increasing, the other is increasing. Because the other is increasing, this is increasing. This regenerative action takes place, okay, and because of that, large current will flow, okay, right? And the junction will break down in very short time. Because this regenerative action takes place, the junction will break down at in very short time. To understand this better, we will consider the two transistor model of SCR. Okay, we will consider the two transistor model of SCR. Okay, so I hope gate closed all of you have understood. Okay, so to make it easier, this one, okay, I have explained here. Okay, I explained this one there, right? So what do you mean by gate closed? Simply from gate to cathode we are connecting battery, okay, right? Fine. So because of this gate current, okay, because of this gate current, what happens? So what happens because of that gate current means the breakover voltage shifts to the left, okay, right? See, this is the breakover voltage, forward breakover voltage when no gate current. When we give some gate current, suppose, okay, we increase the gate current from 0 to some value, small value, then the characteristics, okay, then the characteristics will be like this. The breakover voltage will occur at smaller voltage. The value of the breakover voltage will reduce. Okay, so now the new breakover voltage will be here, right? So this will be the characteristics. This will be the characteristics when you give some gate current. Okay, I will call it as Ig1. Okay, I will call it as Ig1. Okay, Ig1. Now what happens if we further increase the gate current? Very simple. More the gate current, the breakover voltage will happen at lower voltage. What do I mean by that? Okay, the characteristics will follow. If we increase further the gate current, the characteristics will be like this. Okay, the breakover voltage will occur at lower voltage if we gradually increase the, okay, if we gradually increase the gate current, the breakover voltage will occur. Why am I drawing dotted line? Because of the regenerative action. Okay, after this, after breakover, the next point you will get will be this. Okay, you will not get the in between points. When you do the practical, you will not get the in between points. So what happens if we further increase the gate current? Simple, the characteristics of this device will be like this. Okay, right? Only thing you have to remember is if you increase this gate current, then the breakover voltage, see, initially breakover voltage was here. Now the breakover voltage will reduce. Okay, so this is for a different, okay, this is for a different gate current. Say I will call it as, I will call it as I, okay, Ig2, right? Ig2 is greater than Ig1. If you keep on increasing the gate current, the breakover voltage will happen at lower voltage. Okay, I told you why the symbol of the device is like this, because suppose if you give further, if you further increase the gate current, then the characteristics will be like this. Okay, right? And if you zoom into that characteristics, those are nothing but the characteristics of a PN junction diode. The breakover voltage will further reduce. Okay, the characteristics will be like this, right? Now when you zoom into that, when we zoom into that characteristics, they will be similar to that of an ordinary PN junction diode. Okay, right? So that is the reason, that is the reason the symbol of this is something like a PN junction diode. Additionally, you have a gate control terminal. Okay, right? And here, see, if you see VBR, VBR is reverse breakdown. Okay, reverse breakdown voltage under reverse bias condition, right? Okay, when the breakdown occurs, both J1, J3 have to break down. Okay, now if you see at J1, at J1, this is the first junction J1, heavily doped. Second junction J2, third junction J3. Again at third junction J3, the N region is heavily doped. Okay, so because J1, okay, because of that, because this first P region is heavily doped, J1 is thin. Because the second, okay, that is the last N region is heavily doped, J3 is thin. Okay, both the depletion regions at J1 and J3, they are thin, right? The reason is this region is heavily doped. Okay, and the bottom end region is heavily doped. You know, doping is high, depletion region is thin. So this breakdown will usually occur lower at a lower voltage compared to VB naught. Okay, right? So that is about the SCR. Next, what we will do is we will consider the two transistor model of SCR. Okay, we'll go for the two transistor model of SCR. Okay, structure is very simple, right? The structure of this is very simple. So first what we will do is we will draw the SCR. First we will draw SCR. What is the structure of SCR? We know very well. Okay, okay. So this is the structure of SCR. We have seen this several times, right? Okay. Okay, right. So what are the four regions? So you know very well that the four regions are, okay, P region, N region, P region, okay, and N region. Okay, so these are the four regions P, N, P, N. Okay. So next class also I will be taking, right? So what we will do is wherever this class ends, again we will start the next class. Okay, right? Anyway, so meanwhile, until that point, we will continue. So here, and what are the terminals? Okay, the terminals, top terminal. Okay, you know very well this is anode. Okay, bottom terminal, you know very well this is cathode, represented by K. Middle P region, we know very well this is gate. Okay, so this is the basic structure of SCR, right? Now here, if you see the top three regions, it is PNP, correct? If you see the bottom three regions, it is NPN, okay, right? So you can actually say if I represent only the top, if I represent only the top three regions, then okay, the device is like this. I am representing only the top three regions. Okay, I'm only representing the top three regions. So the device will be like this. Okay, right? So this is the, okay, so this is the PNP transistor. This is the PNP transistor. Likewise, the next NPN transistor we will join and we will make the two transistor model of SCR. We'll continue that in the next class. Okay. So all of you should join again at 11:15. We'll continue in the next class.